So hi everyone, it's quite a packed room. It's interesting. Forecasting is getting trendy these days. So the topic I will be speaking about today for roughly 30-35 minutes, then there will be time for questions, is one of my side projects the last year, which involved how to automate the process of forecasting time series. And if you don't know anything about time series or forecasting, I'll try to start from the ground up. So I choose to take a Japanese theme in this presentation because Dataiku sounds Japanese. What is a time series? So this is an example that I found. It's apparently the yearly sales of the top 3 magazines publishing mangas in Japan. So the black one is the weekly Shonen Jump. It's the one publishing, it used to publish Dragon Ball. So this nice hill that you see is the height of Dragon Ball. So that's an example of a time series. The time series is an event that you measure across time. Usually, and that's what I'm focusing on, it's a numeric value. So here, it's measured every year. You can measure it every hour, every minute. Maybe it's not even regular, etc. So it's measurements of a phenomenon. So forecasting, typically if you apply to time series, is about finding the trends, the patterns within your data, and being able to infer the future behavior, so the future series. So if you take that example, I have no clue what it's about, but it's forecasting. I'm probably dealing with temperature. And it clearly shows that this model, this nice line, is able to understand the seasonality aspect in your data. So it's able to extrapolate to roughly the next year. So let me time it. So why is this needed? There's 3 huge domains of applications of time series forecasting. The first one being in finance, if you want to predict a price. So for instance, this is the Nintendo stock. It's happening, it's actually increasing quite well. In the public sector, people use it to plan an economy. Actually, you could wonder why a sophisticated model is needed for Japanese GDP, because it's fairly flat. But it is, because a tiny variation is actually very, very important and has absolutely enormous consequences. And then in retail, CPG, and in the travel industry, it's super, super important. How do you predict the sales and the demand, which is related, but it's actually slightly different to predicting a price in a marketplace. So these are visits to Japan. Even though the Japanese GDP is fairly flat, people are actually interested into visiting this country. It's very nice. If you've not been, you should. So in this session, I'll talk a bit about why I choose to work on this. Highlight some differences between forecasting as a practice and machine learning. Who's here who describes herself or himself as a data scientist? Okay, interesting. And who has practiced forecasting before? Wait, so my internal counter counted more hands at the second time. This is interesting. So some people practice forecasting even without qualifying themselves as data scientists, which is actually one of my goals in making this automated pipeline work. So I'll show a bit how you can use it from within our software, and then discuss some more technicalities about how you choose a stack when you build a pipeline, how you evaluate your performance in a time series context, and then if we have time, spent last night preparing some a demo on Kubernetes for the scalability aspect. So let's start with the why. I don't know who here has heard about this company, GRDF. Not a smaller show of hands. So GRDF is a French company. They manage the infrastructure of gas. They're actually one of the largest if you take the NG, which is their umbrella company, it's one of the largest gas providers in Europe. And I was working with them, that was 3 years ago, and one of their projects was about how to better predict in a certain region in France, in the east, as a pilot, the number of people who would ask to be connected to gas. So even though like it's a fairly old infrastructure, so there are still some people that are not connected, like sometimes even entire towns that would ask to be connected for the first time. And for them, it would be an operational challenge. So they were doing forecasting already, because it's a core need that has been in the business for like the very beginning. Planning activity is a very natural need. But they only had that at top level. So we'd be able to say, well, next year we're going to have X number of requests to be connected, which wouldn't help their local staff, because when you go in the field, I was speaking to one guy who was really, really on the field, and he would say, well, actually, if suddenly I have 3 requests that come up in a certain area, and I have only one guy there, and he's, I don't know, going on a sick leave or anything, it creates a major shock in the organization. So they needed to really plan much better at a finer grain level. And I didn't know much about forecasting, so it was a kind of steep learning curve for me, but we did that. We tried to do it, and actually it was fairly difficult. I'm not sure we actually succeeded, because just the events were so rare, and we didn't have a lot of historical data, so learning from trends does require enough data. But from that kind of semi-failure, so the project never made it to production or was not really used, came this realization that, hey, there is this need of business, people from the business, people from operations to be able to test forecasting method autonomously, you know? Because building these was very ad hoc, but was actually very generic. And yeah, it really all started from this very much industrial, very, you know, the reality of life need. So then I'm working at Dataiku as a data scientist. We're very lucky in the sense that we have some free time to take on personal projects. So I kind of thought a lot internally to say, well, I really think this is a relevant project to work on. And it was not just a straightforward process. We spent a lot of time. Even before I had joined the company, they had this interest in forecasting for a very long time. Roughly 2 years of really active discussions to scope and understand what we could do. And then I spent roughly 40 days, helped by a lot of people to scope it and to develop it. Like developing based on a lot of open source technologies. Definitely happy to talk more about the stack later on. I'll just jump straight into a very quick demo. And for that, I actually think that the best demos are the ones that are improvised. It's also the most risky, so bear with me if it doesn't work. So let's say that you're interested in the latest Google Trends. So what is interesting right now? So I actually did something on Kim Kardashian and Taylor Swift, but I don't want to do that again. No, actually, I'm very excited about this. I don't know about you guys. So let's take a bit more of data, shall we? Past 5 years of data in the United Kingdom, which is more or less an inverted version of the island of Game of Thrones, right? If you see what I'm talking about. And if Google allows me, yeah, nice. So there's some kind of seasonality pattern that you can immediately spot. So let's say you don't know much about forecasting, you don't code in Python or in R, and you just want to say, oh, is the final season, in terms of Google searches, is it going to trigger more searches than the previous ones? You know? So this would fall in the category of maybe planning demand. So Google allows you to export that data. And I'll start with a brand new project. Yay, God. Yep. Okay. So that is what the data looks like. You have one point which is normalized between 0 and 100 for the maximum every week, starting from 2014. So forecasting models are a bit tricky. They need data in a certain format, so we'll clean it very quickly. Parsing the date. Yeah. Perfect. I'll just rename it to a simpler column name. Hadoop doesn't like special characters. And from then on, you have a dataset that is ready for forecasting. Yay. Oops, sorry. Wait. Yep. Forecast. I have lots of other people who are working on other personal projects, so mine is one small piece of a constellation. So typically, the process, you can break it down in 3 steps. You need to clean the time series because often you have irregularities, outliers, missing values. And you cannot have your models learn from it. Then you train and evaluate in a cycle. You do a lot of iteration. And then either you want to use these trained models for forecasting. So that's the typical use case I've been describing. But actually, in this, I'll try to show it on Game of Thrones. There's another use case for anomaly detection. If you get what is called the residuals, so what is the difference between the forecast and the actual value, you can see where there is a point where your time series really diverges from the forecast, so the seasonality pattern, so some kind of anomaly. And these are actually interesting, especially dealing with media like that. So, So passing the column arguments. So here we are dealing with weekly data. So if there are duplicates, I'll take the average. And I'll interpolate the missing values, but I won't replace the outliers. I still want to learn from them since the data is normalized. So that's fine. Okay. Okay. So I have a cleaner data set. Let's get to the interesting part and actually train some models. So here you will output result for the evaluation. Oops, sorry. Yeah. And have somewhere to dump your trained models in. So here I don't have feature, external regressors to put on, but for a real exercise, it would be interesting because things like holidays would be interesting, or weather. Maybe, well, I'm sure anyway, even if it's very sunny, you would still watch Game of Thrones, but maybe it does have a bit of an influence. Actually, when I first watched the first seasons of Game of Thrones, it was like the hottest summer in Toronto, and I would still be absolutely hooked, but it was very weird. Okay, so here you select your models. So if you don't know a lot about forecasting, just use automated mode. If you're an expert and you know these, in the backend, it's using two libraries, Forecast, from a very nice Australian professors who's open sourced this with lots of model, and from a recent library from Facebook called Prophet. So if you know these libraries, you'll recognize these parameters. But let's say you just want things quickly. So you want to try all of these models automatically. And let's say you want to evaluate on the last 10 weeks of the data. I'll speak a bit about other techniques for cross-validation if we have some time. Yeah. So, yeah, who doesn't like to see logs in a talk? I like my logs. I wrote my logging myself. So, yeah, I can tell you that all the models have finished training. So here you're at the cross-validation step. Some of my software developers colleagues said, oh, you should really build a web app. Yeah, I agree. I'm not the best with building interfaces, but here you have raw data. So here, actually, if we sort by error, interestingly, so this is the mean absolute percentage error. So it tells you how much, on average, how much error do you make, plus or minus X%. And so this is sorted. So it's always important to put these numbers into perspective of a baseline. So here the baseline is just saying, well, why wouldn't I just forecast saying that the value at the next week will be the same as the previous one, and always continue like that? It's actually, in a lot of cases where it's fairly random, it's a good forecasting method. And if you forget to compare with this, sometimes you'll train very fancy models without realizing that you're not really improving on top of this baseline. So here the good news is that some models, so here a state space model, in this case, actually managed to improve over this baseline. But for instance, interestingly, Prophet here, actually, this does not improve on the baseline. So let's use the best model to predict and see the next trend for Monday. Actually, I think it's Sunday in the US. I'm very jealous of my fellow Americans. So yeah, I'll just select the best model according to the percentage error, extract the forecast, the history, with the residuals. You can also choose the confidence interval, of course. Most of it is using some kind of Monte Carlo in the backend, for those who went to my previous talk. Monte Carlo is everywhere. And there you have it. So it's raw data. I can try to make it nicer by building some charts. So yeah, every week. And I'll get the interest and the forecast. Yeah. I'll just make it in a nice curve. So it's not too bad, but for instance, here, by the end, I'm not sure my model will be able to really predict so well the grand premiere of the first episode of Final. Let's see. But it does in the past, kind of with a bit of a lag, picks up the trends of the curve. So I'm a bit late on time, so I'll pass a few slides. So going back to the topic of, okay, how is this different from traditional machine learning? So I won't demo it again, sorry, but we do have a public project that highlights this. There are three big differences. The first one is the fact that you deal with multiple outputs instead of a single one, which is the focus of a lot of research in machine learning. So you actually deal with sequence prediction. And that the evaluation strategy is different from, let's say, a binary classification like a fraud classifier. And the literature and the open source world of time series is different. Most of it is in R. There are some things in Python, but not as much. So you cannot completely just plug it. Open source doesn't work like that. You need to do a lot of plugging yourself. Yeah, so that we did. So where will the slides be made available after this?
I don't know. Yes, I think they will be.
Okay, awesome. So you'll be able to do all of that. So a few words. So that's the technical part. I hope I don't lose anyone. Please ask questions after if I'm not clear. So this was a bit of a case when I started this project of comparing R with Python. And this is a graph from KD Nugget. It's a poll. And just I'm using both. And when you deal with such projects, it's a bit hard. You should really consider them as tools and don't come with too much of a prejudices. It happened that Python is a bit more modular, but didn't have the libraries that I needed to build this quickly. So I choose R. Also because I think it's not the right angle, well, unless you have a lot of time, to re-implement things that have already been implemented, and that's actually a lot of work. This complex graph kind of still shows that there's a positive flow from R to Python, and not vice versa. So anyway, so I choose to be a nice guy and to let R win. My final message would be if you know of anyone or if you want to spend time on an open source project, definitely time series forecasting in Python, please anyone. There are some stuff, but just, not as well maintained as I wish it would be. I'm aware of stats model, by the way, but there's not all the models that I wish there would be. Next, on specificities of time series cross-validation. So you need to respect time. There's a very simple way to do it, which is just to split based on time. But actually, it's not the best way because you could have the last 10 observations of your data on a flat time, and it just would fail to tell you that your model actually doesn't model peaks. So actually, there's a much better way, which is time series cross-validation. So there's an excellent article by Rob Hinman, the guy who's managing the Forecast R project about this. But the idea is that same as a k-fold. You split multiple times, and you have sliding windows of cross-validation. So these are all the folds, and at every time you try to predict 1, 2, 3, 4, etc. steps ahead, and then you average the performance across all of these. So that's a bit hard in the sense that you have to do that a lot of time, so as many steps, as many steps as you have in the time series. There's a kind of better, smarter way that Facebook Prophet introduced, which just takes this same idea, but doesn't require to train as many times as steps. But they introduce two notions: the notion of initial training, because it's worthless to train models when you don't have enough data points. So you want to only start with k-fold after an initial window. And then instead of training every step, you can have a cutoff period to say, well, retrain every X week. And that makes it, you still keep the cross-validation, so the robustness, but it's faster to run. So in the last 5 minutes, I'll do a quick demo of how you can make it scale. I know R and scalability. I can see some puzzled faces. It's actually, yeah, you can make it work with a bit of engineering. But the trick is up. So I have here, who here has used Kubernetes in the past? Wow, okay. I think next year there will be a lot more hands. So Kubernetes is a nice technology for orchestrating container and making R and Python job scale. You can actually make Spark job scale very well as well. So in a way, it could be a competitor to Yarn if you come from the Hadoop world. Wow. Why is there suddenly a lot of light? So the good trick of this is from a data engineering perspective that you can pay only for what you use. So here I have a Kubernetes cluster running on a Google Cloud Platform that has 3 pods, right? And so I was dealing with a Kaggle competition. So you may have a work on it. It's the Walmart competition. So you need to predict the weekly sales of Walmart across multiple stores at multiple departments. So what I did was simply to partition it, so to have one file for each. And so you end up having multiple partitions. Partitions. And you want to train one model separately for each partition. So I build exactly the same process as I showed you with a simple weekly Game of Thrones Google Trends. And looking at the process of training, you want to run it faster. So you want to use a container. So, okay, and I build all the combination I want. So I have 500 partitions in this. And I won't have time to let it run completely, but the idea is that it fires up a lot of container, and thanks to auto-scaling, here in the Kubernetes console, you'll be able to see that the number of pods will increase, because at every given point in time, this will ask for more CPU to the Kubernetes master, and nicely auto-scale. There's a lot of very smart engineering that is beyond my means here, but with a bit of an help from one of my fellow architects, we could make it work. Yeah, suddenly I now have 7 pods. I have a maximum of 30, and after I swore to my colleague that I would shut it down because these nice beasts do cost a bit of money. And so yeah, So it already has processed 12 partitions, and it will do the 500 nicely. And with that, so I had it run previously, so I can show you that it can give you some nice benchmark, like how many times does one particular model work best. Because here you do your model selection at partition level. So actually, I found that in this particular case, the neural network architecture from the forecast package is quite effective. And state space, which was the best for the Game of Thrones case. And you can do some nice forecasting of whatever this product is. Maybe it's ketchup. Probably not. Ketchup would be more, yeah. And have a view of where your model is failing. Oh, okay, yeah, for this store, I'm not getting a great model. All right, so to wrap it up, the floor is open for questions.
Got about 10 minutes, so far away. Yep.
Yeah, much better.
As your data irregularly spaced, how do you deal with irregularly spaced data, and how do you deal with spikes?
Yeah, thanks. Those are two excellent questions. So to your first point on irregularly spaced data, I took the hypothesis that on the first recipe that I built, so this recipe resamples at a fixed interval, so up to the hour. In real life, there's a lot of smart techniques that can deal with this. But if you really want to feed to a lot of different model types, the only way to make it work is to make it regular somehow. So to your second point on spikes, so spikes, well, it depends on what industry you work in and what the spike means. If you work for Twitter, well, probably the spike is really because there was suddenly a viral tweet. That's not the same as a spike for IoT. And IoT, a spike might be a data mistake. So in that case, you need to detect and remove a spike. So, yeah. Yeah, okay. In that case, if it's not a data mistake, it's up to judgment. I would tend to test both and see what works best. Also, what do you want to do with your forecasting model? Is it really about forecasting, or do you want actually to use it for anomaly detection, in which case you would keep these spikes?
How do you deal with non-stationarity in your models? Oh, how do you, sorry, can you hear me now?
Yeah.
How do you deal with non-stationarity? It's the models, you have very simplistic assumptions.
Yeah. So in here, the model implementation that I've used deal with this internally. So I trust that they are doing their job correctly. But you're right in the sense, so there is a lot of space for applying actually machine learning and deep learning to this. And I would tend to use these before to stationarize and then apply machine learning once it's stationarized. Else you would do a simple differencing. Sorry?
Machine learning, you'll assume the stationarity model switch. They don't perform stationary well.
Yeah, exactly. But if you detrend with these, then you get a stationary time series. So you would be able to apply it at a later stage.
Thank you very much for a very interesting talk. What is the difference between state space and traditional forecasting models?
So those are different implementations. So state space modeling, I'm not an expert, but the modeling of a time series would be different from, let's say, an autoregressive neural network. It's a bit like the difference between, I don't know, XGBoost and light GBM, or maybe XGBoost and logistic regression. These are two different implementations that in the end serve the same goal.
And one here.
Thank you for the demo. When you're doing the model comparison, what happens if the baseline naive forecast wins? And what's your typical next step? So say, your naive forecast comes on top, and your stakeholder is not happy with that straight line of forecast. What's your typical next step?
Yeah, that's a good question. That's a really good question. So some things are difficult to forecast. One piece of advice I would have is maybe you're missing some data. So there are some, like time series forecasting, some models can use external data, like weather, holiday, or anything. And maybe if you acquire these, you'll be able to better explain your phenomenon. So I've tried ARIMA and a different architecture of neural network, but separately. But I didn't know that there were some papers to combine it. So it'd be interesting to know more about it.
Any questions? Yep.
Hi. So how often do you retrain the models once they are in production? And sorry, how do you split the work between the pods? Is it a model, like training model per pod, or?
Yeah. Yeah, those are interesting questions. Thanks. So for your first question, how do I retrain? So here I would just have one new model for every time I retrain. So it's fairly simplistic. I just, yeah, it's a brand new model. It's not like online learning. Then for the scalability, it's just one model per pod. Sorry. So again, I took very simple assumptions.
Two last questions. Anyone got? So yeah, one over here and one over here. Great.
Hey, thank you so much for the really good presentation. The previous question you mentioned that if a model is not really good, it's probably because of external data sets. And a lot of them are very classic, whether it's the one you mentioned, holidays you mentioned, maybe religious holidays, things like that. Dataiku is an amazing tool, but as far as I could see from far back, I didn't see any include well-known public data sets as an option. Is it something you're planning on doing? Is it something that would make sense for you? Is it a feature that you think would improve your ability to predict?
Yeah, well, thanks for the kind words. So as far as joining data, well, you can join whatever data you want. If you have data, either open data or commercial data, on the right date, you can join on it. So far, what we have bundled is just public holidays and things like that. Well, actually, we can talk maybe if you want to include others after this. Yeah, sure.
Hi, thank you very much for your talk. I'm just wondering if your MCS based on in-sample or out-of-sample data forecast, and are you able to calculate out-of-sample forecast? Thank you.
So on that, yeah, I know some different terminology, but I think to take, yeah, it's out of sample. So I mean, I train on a specific segment, and then I test on a complete different one, which is always later on. So the model has never seen the subsequent data, but for just speeding up, I did take an assumption that estimation of parameters, so grid searching, would be learned on the whole data. Because I still need a candidate for deployment in the end. So I still learn the parameters, like for an ARIMA, in the entire time series.
Okay, thank you. Loads of questions, but we're out of time. So can we just, to end, thanks Alex in their traditional way.